We're back. We're going to work a definite integral with integration by parts. But to begin, we're only going to focus on just the integration piece. So we're really only going to focus on the integral of arc sine of x dx, and then we'll worry about the bounds using the fundamental theorem of calculus. Again, typically we'd start talking about this within the class, but we aren't granted that luxury. Therefore, we'll have to make do. Our first option is to have u to be arc sine, and because of my room, I'm just going to use sine inverse of x, and dv would be just dx, because there's only one piece remaining. Option 2 would be that u is equal to 1, and dv is equal to arc sine x dx. And hopefully we quickly realize u equaling 1 isn't helpful because the derivative of 1 is 0. And that puts you straight back where you started. So you don't want to use that option, obviously. So our option is u equaling arc sine of x and dv equaling 1 dx. Du, the derivative of arc sine, is 1 over the root of 1 minus x squared dx, and the integral of dv, which is just 1 dx, would be x. Now we have a good setup to begin. Please go ahead and write out our first piece, which is the integral of u dv is equal to u times v minus the integral of v du. It's just to get the formula maximized in that brain so you have it floating around in there when we need to recall. U times v would be x times arc sine of x minus the integral of x times du. That would give you x over the root of 1 minus x squared dx. To integrate, we need to use u substitution. U is 1 minus x squared. The derivative of u, which is kind of probably a little bit confusing because we're switching things up here and using the same variable, but if you don't like that, you can use w's and dw's if you would like. And du is negative 2x dx. We do have an x, but we're missing a negative 1/2 and a negative 2. Therefore, we have x arc sine of x plus 1/2 of the integral of u to the negative 1/2 du. And the integral of u to the negative 1/2 is 2u to the 1/2. Therefore, our 1/2 and 2 cancel. Then we have x arc sine of x plus the root of 1 minus x squared. Remember, this was a definite integral, so I am going to put our vertical bar with our bounds now for a function, and that's along 0 to 1. Therefore, we have 1 arc sine of 1 plus the root of 1 minus 1, or 0, minus 0 times arc sine of 0 minus the root of 1 minus 0, or 1. This goes to 0. Arc sine of 1, sine is equal to 1 at pi over 2. Therefore, arc sine of 1 is pi over 2. 1 times pi over 2 is pi over 2. And then we have minus 1. That would be an acceptable answer for the AP board for a multiple choice question without a calculator, but just so we know, the approximation, if we were allowed a calculator, is 0.571. Please reach out to me if you have any questions about that example. I am happy to help. Then our next example, we have x squared and sine of x. And we need to figure out which one we would like to be u and which one we'd like to be dv. Our options. First option is u is x squared, dv is sine of x dx. Option 2. U is sine of x, dv is x squared dx. And really you could have the options where one of them's 1, the other one's the rest of it, etc. But really and truly we have 2 options that are viable. And option 1, u would go to 2x dx when we took the derivative, and the integral piece isn't bad. But within the second option, the integral would actually increase, so that's not very helpful. So we are going to go with option 1. U equals x squared, dv equals sine of x dx. The derivative of x squared is 2x dx. The integral of sine of x dx is a negative cosine of x. Now we have our setup for integration by parts. The integral of u dv is equal to u v minus the integral of v du. And we have negative x squared cosine of x minus a negative, so that would be plus the integral of cosine of x times 2x, or 2x cosine of x dx. As the heading of our example implied, we kind of hit a roadblock. We can't integrate 2x cosine of x either. So we're going to have to set up a new a new integration by parts with u and dv. And we want to keep a common theme, but just adjust it according to what we currently have. Within our first piece, hopefully remember that u was x squared, so this time our u should be 2x. Therefore, dv should be cosine of x dx. The derivative of u would be 2 dx, and the integral of dv would be sine of x. Now we want to place this in. I'll use purple for my initial piece and green for my remaining until we get to the end, and then we'll choose a color. Now we're at plus u times v, so that is 2x sine of x minus the integral of v times du, so that's 2 sine of x dx. We've finally reached the point where we can integrate. Therefore, we have a negative x squared cosine of x plus 2x sine of x. The integral of negative 2 sine of x would be a positive 2 cosine of x plus c. And that is our final answer from integration by parts. Hopefully that makes sense. If you have any questions about the repeated use of integration by parts, please reach out to me. I'm going to go ahead and cut the video. We're going to work our next example, which will be a little bit intense, so be prepared. And hopefully it'll make sense in the end and it'll be helpful. Thank you for taking time out of your day to watch this video series. Make sure you continue on. Thank you.